Hello. Today I am going to discuss with you about methods that are used in measuring laser rods, parallelism. This is a spec that is very important for the customers because it dictates the spot quality, which is very important. This is what we are doing. We manufacture the laser rods and of course supplying them with the data that is going with the rod. And we found out that some customers complained that the data that we supply on parallelism measurements is not matching what they get when they measure them in-house. This issue was a little bit annoying, so we decided to go deeply into it and find out where could be the difference. Let's see what the customers generally are using in measuring parallelism. We found out that everybody is using a sort of autocollimator, not the best one, not the most expensive one, and they are getting results. It's a 2x and y marks. They try to match them, and if it's matching precisely, it's okay, and if it's blurring a little bit, it's not okay. We have a more scientific way to measure it through a Zygo interferometer. In the Zygo interferometer, what happens is that the beam, the wavefront, is a portion of it is just going back to the camera, and a portion of it is continuing into the road, coming back from a reference mirror, going into the camera, and the software is calculating, considering the index, refractive index of the material, is making the calculation, what is the angle deviation that happened. So this is the interferometer system that is known and supposed to be accurate. Now we decided that we want to be more accurate. So we bought a very expensive instrument from Trioptics, and this Trioptics station for measuring rods is combined two electronic autocollimators that are precisely aligned on both sides together, and the rod is in between. What the system of Trioptics is measuring is the reflectance from the ends, then calculating the deviation of the angle and is giving us the results. Why do we think that this is more precise and true value? Because when the interference system is working, the beam is going inside and back two ways. So we have to consider effects of the material. The material is not supposed to be always uniform. There is some index inhomogeneity that can cause a deviation from the real true value. So we believe that the Trioptic is even more precise than the other one and is really the true value. Of course, if the Trioptics system is terribly expensive, we will not expect every customer to invest so much money in it, but we invested. So that's why we believe that we can supply today a real value that is true, and maybe, I'm sorry, that sometimes it will not match the basic measurement done by the customer, but I can guarantee this is a true value. Thank you very much for being with us today. We hope that you enjoyed and it will be helpful for you. We are here. If you have any more questions, we will be glad to assist you. Call us and meet us in the next video. Thank you very much.